Hello again, boys and girls.
Hello again, boys and girls.
And cougar parents.
And cougar parents.
Can I hear a cougar roar?
No.
Oh, okay. Well, not today. Today we're going to take a look at volume. Volume. Can you say pump up the volume?
Pump up the volume.
Yeah. When we look at the volume of a three-dimensional figure, what we're really doing is we're seeing we're stacking the bases, and we'll talk a little bit of what that means. Volume also deals with three dimensions, whereas when we're dealing with area and surface area, that was just 2 dimensions. We're looking at the base and the height, also known as the width and length. Now we're going to add the third dimension. It's that dimension that causes it to pop out at us. Are you okay there? Feeling a little sicky? Okay. Well, let's say bye to everyone as we take a look at volume. Say bye-bye.
Bye-bye.
What you doing?
I'm measuring the dimensions of this polygons.
Okay. Why are you doing that?
So I can find the surface area of this solid.
Okay. Cool. Get back to work. Okay, boys and girls, let's take a look at surface area and nets. Well, first of all, when we talk about nets, as earlier stated, we're not talking about fishing nets. What we're talking about is a drawing or sketch of a 3D figure or a solid, and the way we draw it is we take a look at all of the faces. See, here we have a face, okay, and that top face there is a triangle. We also have a side face there, and also a side face there. So we have 2 side faces. And if I were to get a little creative, and in the back here I'm going to try to create a dotted line, okay, we can see that this top also has a matching bottom. Face. And what we can't see the bottom, and what we can't see as well is, but we know there has to be a back face as well. Okay, so, and by the way, this is a prism. Okay, it's a triangular prism. It has a top face, a bottom face, 2 side faces that we can see in the front, and a back face in the beginning. All together, it has 5 faces. So now this is where the net comes in. If we want to find the surface area of all the faces, the surface area of this solid or 3D figure, what we kind of need to do is we need to kind of peel it. Just peel the faces of the surfaces off. So if we were to peel, what it would look like is we have the one side over here that's folded back. Then we have the back of our triangular prism. And then we have the other side. A little curvy there, sorry about that. So here we have side 1. Here we have the back. And then we have side 2. These are our 3 faces. Here are the 3 rectangular faces, but we can't forget about the top face, which is a triangle, as well as the bottom face that we folded back as well. Okay, and this is our bottom face. So there you have it. You have all four faces. I'm sorry, all five faces of this triangular prism. We folded back the two sides and got these. We have the back face here, and then we have the top and the bottom face, which are corresponding. And see, once we have our net of this three-dimensional figure, the triangular prism, if you take a step back, this should look actually familiar. This is a decomposed irregular polygon, and we can find the area now of the surface area of this figure. We're taking the area of each of the surfaces or faces of this 3D figure. So if, let's say for example, the length of this face here is 5, the length or the width of this, the same side of this face is 2, and let's say the width of this face here is 3. This is also a two units here. So now we have the length of that side. We have the lengths of this side as well. So let's drop a perpendicular. Ding, 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 ding. It doesn't look very perpendicular, but just trust me. There's the perpendicular there, and we're going to say that this triangle is, oh, it's got to be about, we'll say that it is 2 units as well. There you have it. Now see, we can figure out the area of all these sides. This side right here, or this face I should say, this face, which we're calling side 1, is a 2 by 5 rectangle. So it would have the area of 10 units squared. This face over here that we're calling side 2 is matching. It's also 2 wide and 5 high. We can transfer this information all the way over here. So this is also a 10 squared unit rectangle. And this back face, which we can't see over here, but when we unfold it we can see it here, it is a 3 by 5 rectangle, so it would be 15 units squared. So we got the area of that, we got the area of that, and the area of that over there. And now we have to find the area of these two triangles, which have a base of 3, because this rectangle here is 3 wide, then that's also that serves as the base of this triangle, and we know that the height is 2. So what we have here is we want to take the base times the height and then divide it by 2. 3 times 2 is 6, divided by 2 is 3. So this triangle here has the area of 3. This one is matching. It's a corresponding triangle. It's going to have the same area. And now we have the area of all of the faces, the surfaces of this solid figure here, this three-dimensional figure. And see how the net helped us do that? We kind of peeled back all the faces, and then we find the dimensions of each of these faces, which are rectangles and triangles. And now the last step is to add them all up. Well, we have the two faces that we're calling side 1 and side 2. They're both 10 each. We have the back face, which is 15. And then we have the two triangles, which form the base and the top, or the bottom and the top, and they're both 3 units squared as well. Okay, that's a crazy looking 3, but it's a 3. So we got 10 plus 10 is 20, plus 15 is now 35, and then 35 plus 3 is 38, plus another crazy looking 3 is going to be 41 units squared. And there you have it. Okay? So we take our three-dimensional figure, and if we want to find the surface area of it, we can create a net. A net simply peels back all of the faces or different polygons that make up this polyhedron or triangular prism. We get all of the polygons that cover this solid, and what we have is an irregular polygon, and we know how to find the area of the regular polygon. You decompose it, but it's already decomposed for us into all of its base polygons, and there you have it. We add them all up when we're done. So you take your 3D figure, you create a net out of it, find the area of all of the faces of your solid, and then you add all the areas up to come up with the grand total of the surface area of your polyhedron. And this polyhedron was a triangular prism. I think that's enough. You all have a great day, and I hope that this is helpful. Bye-bye.